This would be the last video in your series for Chapter 1, Exploring Data. And in this one, I just want to talk to you about comparing single variable distributions. Now, when we compare distributions, we want to follow the same protocol that we do when we are describing a distribution. So first, we want to make sure that we're using SOCs. We want to talk about the shape, outliers, centers, and spread. We want to make sure that we use comparative language. Words like more than, less, higher, etc. You want to make sure you're using that comparative language. Make sure you keep the description in context. Always keep in mind the variable that you are discussing and insert that variable name into your description. And lastly, the types of plots we can use. I'll show you all three. We can use back-to-back stem plots, or we can use parallel histograms, one histogram on top of the other, or we can use parallel box plots, one box plot on top of the other. If you don't already have your pulse rate sheet from class, you may want to go ahead and grab that so you can see how we created this back-to-back stem plot. For the male pulse rates, it is very similar to the way that we created it in class, being that this stem plot is on the right-hand side. So my stems are 4 through 12 to represent tens, and my leaves are the ones place of all the pulse rates of the students in both classes. And so again, we just list the stem in numerical order for each, we list the leaf in numerical order for each stem that we are given. Now, on the left-hand side with females, we do the same thing. We just list the stems from right to left instead of from left to right. So there were no females that had pulse rates in the 40s. We had one female with a pulse rate of 55. When we get down here to the 70s, we had 3 with 70. 2 with 75 and 1 with 77. And notice that we're listing these from right to left as we go. And so if you start to look at the shapes of these distributions, then you get a feel for how they compare. Now, I showed you in class how we can rotate the stem plot 90 degrees counterclockwise to view its shape. And you will see that here with the male pulse rates. So when we look at the shape of the male pulse rates, how would you describe this? So draw a little curve around this, so maybe it'll give you an indication of what's happening. So how would you describe that shape? My hope is that you were thinking or said skewed to the right. Now with the female pulse rate from the back-to-back stem plot, you're going to have to not only rotate it, but reflect it vertically so that the numbers in the stem are in the correct order. They go from 4 to 12 as opposed to 12 to 4. And so if I were to draw a curve around this one, it may look something like this. It's not the best looking curve in the world, but I think you get the idea of how this one would look. And so how might you describe this curve? Some of you may be thinking skewed right, some may be thinking roughly symmetric. So sometimes the stem plot will give us an idea of that. We can also create parallel box plots and parallel histograms. And you see pictures of those here. The parallel box plots, the top is the female group. You see it indicated with F here. The bottom is the male group. You see it indicated with M here. And so I'm not sure if this gives us some better idea of the shape than the stem plot would. But you can start to see in the female group how this kind of peaks up and then comes back down. Now these are on the same scale. Perhaps if I change the scale, we would see something different. However, whenever we're comparing, you want to always compare the distributions on the same scale to make it an equitable comparison. In the bottom, if I were to kind of trace the male distribution, we could still see that peak and then kind of skewing off to the right. If we were to flip our attention or switch our attention down here to the parallel box plots, again, we have the female group on the top and the male group on the bottom, then we can compare some things. Right away with these modified box plots, I first noticed that the male group has outliers. And so I'm going to leave it up to you to verify those using the 1.5 IQR rule, and we'll talk about that in class tomorrow if we need to review that. I also noticed that the box itself, the female box is farther to the right than the male box is. The female box also happens to be wider than the male box is. And so hopefully that gives you some indication of what is going on in the female distribution of pulse rates and what's going on in the male distribution of pulse rates. And so when I see that this entire box that represents the middle 50% of the female distribution is farther to the right than that of the male box, that gives me an indication that females tend to have higher pulse rates. When I see that the male box in just its width is shorter or less wide, I should say, than that of the female, then that gives me an indication that the male pulse rates are perhaps more consistently spread than the female pulse rates. There's less variation in the male distribution than there is in the female distribution. We're almost ready for our description. This shows a numerical summary of the distributions of male and female pulse rates. And so beneath the table, the summary table, you have what each row represents, but I'll also write these out to the side so as you're looking at this, it may be more convenient for you to tell what's going on. So the top row is the mean. The first mean, the 81.8 is for females, 72.8 beats per minute for males, and then of the total group, the mean is 75.8. The next row represents how many there are, so we'll call that the letter N. S3, row 3 is the standard deviation from the sample, which is S. Then we have our 5-number summary. So then we have our minimum, Q1, our median, Q3, and our maximum. So as you're comparing, as you're looking at the numerical summaries, again, you want to start to get an indication for what's going on in these distributions. I see that the females have a higher mean. They have a higher standard deviation, higher minimum, higher first quartile, higher median, higher third quartile, higher maximum. If I subtract Q3 minus Q1, I'll also notice that they have a higher IQR. So right now, again, I'm just kind of supporting the idea that females tend to have higher pulse rates, but those pulse rates also tend to be more variable based on the standard deviation and the difference between Q3 and Q1 in the IQR. This slide is just a copy of the template that I put up for you right before the last video, and so you might want to have that handy as well. But I'm going to use this same template. I'm just going to insert some comparative language so that we can show we are actually doing a comparison, rather than a bulleted list of attributes of the female pulse rate distribution and bulleted points of attributes of the male pulse rate distribution. So now we're going to tell our story behind the data. So now we're going to talk about the shape, outlier, center spread, or the SOCs of these distributions using comparative language. Let's begin with the shapes. The distributions of female and male pulse rates are both skewed right, indicating that both groups tend to have lower pulse rates. However, the female distribution appears more skewed than the male distribution of pulse rates. If you look back at those box plots, you will see that the median for the female distribution was closer to Q1, but the median of the male distribution was closer to Q3. And that's where I get this idea that the female distribution appears to be more skewed. You wouldn't necessarily see that in the histogram, nor would you see that necessarily in the stem plots. But from reading the box plots, which don't matter, the scale has no effect on what we see in the skewness of the graph, we can draw that conclusion. Now moving to outliers, and again, you can verify these for yourself using the 1.5 IQR rule. While the female group has no unusual pulse rates, the male group has 4, 1 on the lower end and 3 on the upper end, 45, 100, 103, and 110 beats per minute. Then moving to the center, females in this group tend to have higher pulse rates, that should say than males, as indicated by medians of 77 and 72 beats per minute, respectively. And again, this is just comparing the medians. You can see this in the box plots, and you can also see it in the numerical summaries. And lastly, we want to talk about the spread. Female pulse rates are less consistently spread about, that should say median, than those of males. We use the IQR to discuss this, so we want to talk about the median. This is evident in the spread of the middle 50%, which is the IQR. We had an IQR of 24 for female pulse rates and 19 for male pulse rates. So that's the complete description. Notice that we are still talking about the shape, outlier, center, spread. Not only that, but we're using comparative language. Are both skewed right? The female distribution appears to be more skewed. While the female group has this, the male group has something different. Females in this group tend to have higher pulse rates. Female pulse rates are less consistently spread. So you want to use that comparative language as you go through this. I hope this gives you some insight. Again, if there are any questions you have at all, be ready to ask them tomorrow in class where we will practice like crazy. We have a quiz scheduled for Tuesday, and your response bias projects are due on Thursday. So I will see you guys tomorrow. And again, I hope this helps.